So the video will be recorded. If you have any question, don't worry, speed up. Your voice will not be recorded. Only what I speak and what we have here will be recorded. The chat will not be recorded. Your question will not be recorded. All right. Once again, we have vertical angles have been equal, like 1 and 3 and 2 and 4 equal. And form two parallel lines form 8 angles, and the angle either add up to 180 or they're equals. So the angles here I just write angles are equal or add up to 180 degree, or they are supplement. Right. Quick check. 4 and 6 equal, both of them acute. 3 and 6 add up to 180. 4 equal to 6. 3 plus 6 equal to 180. Those are the relation. Okay, now with this problem, find the measures of angles 1, 2, 3, and 4, given that M and N are parallel. So now with the angle 1 is 3x plus 2, angle 2 don't know, angle 3 don't know, angle 4 is this. Now what is the relation? What is the relation between the angle 2x plus 2 and the 5x minus 40? Well, those two. They look the same. Both of them acute. Both of them less than 90 degrees. So they're equal to each other. So angle 1 equal to angle 4. So we have 3x plus 2 is equal to 5x minus 40. Now we just solve for x. That's easy. Just minus 5x minus 2. So we have minus 2x equal to, that cancel, negative 42. Divide by negative 2 on both sides. Well, x equal to 21. Okay, so with that we can have angle 1 is equal to 3x plus 2, 3x plus 2, and x is 21. Plus 2. 2 times 21 is 63 plus 2 is 65. And angle 4 is the same as angle 1. Therefore should be also 65 degree. And then we need to find angle 2 and angle 3. Angle 1 and angle 2 add up to 180 degrees because they're on a straight line. So we have angle 1 is 65 degrees. We already know that. Angle 2 is 180. Subtract 65 on both sides. 180 minus 65. 115. Okay, 15. That angle 2. And then angle 3. 1 and 3 are vertical. They're opposite from each other. So vertical angles are equal. So angle 1 is the same as angle 3. Or I should say angle 3 equal to angle 1 and equal to 65 degrees as well. So 1 is 65, 2 is 115, 3 is 65, and 4 is 65. That's what we have. Okay. Next, we have triangle. So triangle is a polygon that have 3 angles and 3 sides or 3 vertices. The normal convention is that we have the capital letter. Opposite to that is a lowercase b. Opposite to big B is a little b. Opposite to big C is a little c. So big letters, capital letters for vertices, for angles. Lowercase letter for side. Okay. And they're opposite from each other. Big A, big B, big C, little c. So uppercase, that for vertices or for angle. And a lowercase letter for side. And the sides opposite to the respective angle. Okay, so that's what we have for triangle. Okay, so big letters for the angles, for the vertices, lowercase for the sides, opposite to each other. Right, there is some facts about triangle. Angle sum properties. The sum of a triangle, the sum of the angles in a triangle add up to 180 degrees. So meaning that A plus B plus C is equal to 180 degrees. By the way, instead of write the measure of the angle A, I'm just going to say A as the measure of angle A. So that's easier. So A is going to be the measure of angle A plus the measure of angle B plus measure of angle C is 180. So why is that? I'll do a little proof here. I'll draw a triangle first. Let's say that angle A, that ABC, a triangle here. Okay, now I will draw a parallel line to this. Okay, now we have the angle A inside a triangle. So that's A. Now this angle B, because these are parallel line, that is equal to this angle. Let's call this angle A1. They're equal because there's a transversal here. Similarly, angle C here be the same as this. Let's say that angle A2. Right? So angle B is equal to angle A1. Angle C is equal to angle A2. Notice that. So in that case, we will say A plus B plus C angle B is equal to A2. So angle B is equal to A1. Angle C is equal to angle A2. And when we add them, A1, A, and A2 all together form a straight line, therefore is equal to 180 degrees. So that is the proof. All angles inside triangle add up to 180 degrees. Okay, next we have the triangle inequality. So triangle inequality is that if you add any two sides, the sum of any two sides is greater than the length of the third one. Now if we have, okay, that's very easy to visualize. If we have one side that is way too long and the other two sides that too short, there's no way these two touch each other to form a triangle, right? So the triangle will not be complete if one side is way too long compared to the other two. These vertices will never come together to form a triangle if this is too short. Doesn't matter how it swing, it's not going to have it. It will not touch to make a triangle. So we require to have two sides add up together longer than the third one for that reason. Next, the angle side properties. It says that the larger angles opposite to the longer side. So larger angle, larger opposite sides. So in this case, you see that the angle A is bigger than angle C. So in that case, this side opposite to the smallest angle is the shortest side. Opposite to the biggest angle is the longest side. So the ratio, they don't have the ratio, they have the order. Biggest angle will face the longest side, and the smallest angle will face the shortest side. Okay, and next we have area of triangle, just 1/2 base times height. If we draw the height, and this is the base, so the area is 1/2 base times height. Okay, right, so that's some facts about triangle. Okay, now let's do some example. In this triangle, we have 3 angles like that. For all intents and purpose, let's label them like A, B, and C. So easy to call them. So just label A, B, C. Now A plus B plus C is equal to 180 degrees. And now just substitute all the numbers in. A is 39 plus X. And B is 70. And C is 26 plus X. I'm just going to write the degree for a moment. And now we just solve for X. Okay. Combine like terms 39, 70, and 26. 39, 70, and 26. That is 135 degrees. And then we have 1x, 2x equal to 180 degrees. I just write the degree for a moment. Now we solve for x. Minus 135 on both sides. And that gives us 2x equal to 45 degrees. Again, should just drop the degrees. And then divide by 2 on both sides. We have x equal to 22.5 degrees. And now we have x. We can easily find angles in the triangle. A is equal to 39 plus x. and x is 22.5. That would be 61.5. Let's put the degree. Angle B is 70. Angle C is 26 plus x. .5, and that is 48.5 degree. Right, very simple. Three angles in a triangle add up to 180 degrees. Right, more on triangles. There are different types of triangle. If we classify based on the angle, we have acute, right triangle, and obtuse. If we classify based on the sign, we have equilateral, isosceles, and scalene. Right, let me just draw down what it looks like. A right triangle is where the triangle have a right angle. Okay, this one is just with a right angle. We call that a right triangle. Okay, and now if we have two triangles that have not a right angle, will be just like this, nothing special. Or we have an obtuse angle. So this is the acute triangle. All angles are acute, and this is obtuse triangle because one angle is bigger than 90 degrees, so that's obtuse. So this is acute triangle. And this is obtuse triangle. Okay, acute triangle, obtuse triangle, where there's obtuse angle. And both of this are acute or obtuse triangle. We call that not a right triangle. And there's a name for it. Not right triangle is called oblique triangle. Okay, so that's how we classified it based on angles. Just terminologies here based on angle. Now if we classify based on size, we will have, okay, just draw by hand here. If three sides are equal, this is called equilateral. If we have two sides equal and the other side is not equal, this is called isosceles. So let me spell it. So two sides are equal, two sides equal, and the other there's no equal size, and that's called scalene. Okay. So classify by size. Right. Next we have two triangles, and two triangles that are congruent. Congruent meaning equal, pretty much. So that's the reason they call congruent. Congruent, kind of like the shape are the same. Congruent. Two triangles are congruent if all the sides are equal. But that's a bad statement to say. We said the corresponding sides are equal. So let's say this two triangles are the same. So this equal to that and that equal to that. I mean, corresponding angles are equal. Corresponding sides are equal. So two triangles are the same here. Yeah, so in that case, angle A is same as angle M, angle B is same as P, and C is same as Q. And AB, the length is equal to PM, and so on. So corresponding angles are equal, corresponding sides are equal. In that case, a triangle has three sides and three angles. So we have three pairs of equal angles, three pairs of equal sides. Well, that's 6. But in reality, if two triangles are equal or two triangles are congruent, we don't need only 6 of them. 3 will be enough. But not just any 3, some particular 3. So the case for the triangle to be congruent, okay, so sine, angle, sine. So a sine equal to each other, an angle in between and the other side. So an angle between the two sides. If we have 3 of those criteria equal to those 3 criteria, then those two triangles are equal. So this is sine, angle, sine. Another set of criteria is angle, sine, angle. A sine between two angles. This angle equal to that angle. This angle equal to that angle. I mark them the same way. And the sine here, the same as that. So angle, sine, angle. A sine between two angles being equal, they will be equal. And the last one is the sine, 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 meaning all 3 sides are equal to each other. The corresponding sides are equal. I should mark corresponding side. That equal to that. And this equal to this. And this equal to that. So 3 corresponding pairs of 3 corresponding pair of equal sides, they're equal. That side, side, side. What not the case is this. If we have a side, if we have an angle, and then you have a sine, angle, and the sine, and then a third sine. This is called the angle, sine, sine. Okay, I don't want to abbreviate that. Okay, sine, sine, sine. This is angle, sine, sine, like ASS. I'm not going to write that down. But if we have like this, angle, a sine, and then another sine, we can form this triangle. But if we have the third sine, it can be only this, also this. So we might have this triangle, or we have this triangle. So there are 2 scenarios. So the angle sine, sine will not form a congruent triangle. Okay, we'll revisit this in chapter 7. Right, so that was congruent, meaning equal. The sides are equal. Similar triangle are triangle where we have the angles are equal. The sides are proportional. So an example of this is a map. Let's say we have distance from Dallas from Houston on the map is this much, compared to the actual distance in real life is like 250 miles. But the shape of the state of Texas on the map is the same as the shape of the state of Texas in real life. Except in real life it is on the earth it's a spherical shape, so that's different. But you get the idea. Proportional. So similar triangle, the angles are equal, the sides are proportional, so the ratio will be the same. So in that case, I'll give you an example here. We have a very small triangle. Let's say ABC, and a big triangle, bigger triangle, but similar. Okay, I'll try to draw it. Okay, and let's say M, P, and Q. Now, if these two triangles are similar, we say angle A is equal to angle M, angle B same as P, and angle Q C is equal to angle Q. Right, corresponding angles are equal, and then the ratio are proportional, or the sides are proportional, meaning, okay, I write ABC, triangle ABC, and triangle MPQ, they are similar, so the angles are equal. Now the ratio, what do I have? The first two, AB over MP, first two equal to the first and the last, AC over MQ, and then BC over PQ. So that the ratio of them will be the same. So proportional, size, and equal angles. Right, so that's the properties of similar triangle. Now let's look at this example. These two triangles are similar. Let's find the shape. So we have the ratio here, 4 over y over x over 10 equals 6 over 12. So one side here divided by the others, corresponding, those ratios is going to be the same, constant. Okay, and let's just solve for x and y here. If I take this two ratio and cross multiply, we solve for x. So cross multiply, 12x equal to 6 times 10. So 12x equal to 6 times 10, and that's 60. So 12x is 60 divided by 5. So x equal to 12. Okay, so that was that, x 12. Sorry, I don't know. By the way, if I did something wrong, if I do something wrong, please let me know. Divide by 12 on both sides. So x is equal to 5. Sorry. X is 5. Now, we take a look at the other ratio. I group the first two, the first and the last. Now cross multiply, 4 times 12, 48. And 6 times y. And so forth. y. So that gives us 12. 48 divided by 6 is 8, and y is equal to 8. So similar triangle or similar of anything, the ratio of corresponding sides, the corresponding sides are proportional. Their ratio will be constant. And this is sounds small but very important concept in trigonometry. Pretty much trigonometry based on that fact. Okay, now let's work some other problem. Suppose that DE and BC are parallel, so we have two parallel lines. With parallel line like that, automatically we have a transversal, and this angle is the same as this angle, and this angle the same as this angle, because of a transversal or parallel line. Now with that, we can write the triangle ADE and ABC are parallel. Are similar. So we write out triangle ABC and triangle ABC and ADE are similar. Because A is the same as A, B is the same as D, and E is same as C. So we have corresponding angles are equal. The angles are equal. That's similar. We don't need any sides here. As a matter of fact, only two angles are needed to be equal. So these two are equal. These two are equal. The last one must be equal. Because they all add up to 180. If two of them are equal already, the last one must be equal. Alright, now it's equal. So the angles are equal. But what about the sides? So we write corresponding like this. So we can say AB, the first two is equal to over AD. AC, the first and the last, is equal to AE. And BC over DE. Last two, DE. Okay, now let's put the measure into that. AB is 8 plus 4. AB is 8 and 4. So 12. AD is 8. Okay. AC is going to be 9 plus X. AC is 9 plus X. And AE is 9. BC 16. And DE Y. So the ratio of corresponding sides, that ratio are the same. So the sides are proportional. Right. Now we can solve for X. Group this and cross multiply 12 times 9. That 108. And then 8 times that. So 108 is equal to 72 plus X. Subtract 72 on both sides. I'll have 36. So X is equal to 36. I forgot the AX here, right? Sorry. So minus 32 on both sides. And then divide by 8. So X equal to 36 divided by 8. 36 divided by 8. That 4.5. Okay. And now if we use the other ratio, that's not going to help because we have both x and y, so don't use that. Rather use 12 and 8 is 16 and y. So 12 over 8 is 16 over y. Only one variable, so easy to solve for. Cross multiply 12y is equal to 16 times 8. That's 128. And divide by 12 on both sides. Just have 128 over 12. If we reduce that by 4, 32 over 3. Okay, that's a similar triangle. The ratio of corresponding sides are equal. Right, next, we have also another similar triangle here. So I have the building that is 10 meter height casts a shadow of 18 meter. At the same time, this is very important. If it's not the same time, the ratio of the sun relatively to the building and the flat will not be the same. The shadow is not proportional. If at the same time, then that will be we have similar triangle. This very classic problem. We can find the shadow and the actual length. In that case, if we want the flagpole, the shadow is 27. We can set up the ratio. See, the question asks for what is find the height of flagpole. Let that be x. So read the problem real quick. So the worker must measure the height of the flagpole. To find that at the instant meaning at the same time, the shadow is 18 meter, and the shadow of the flagpole is 27 meter. What will be x? Now we have two similar triangles here, and so we'll write 18 over 27 over equal 10 over x. So 18 over 27 equal 10 over x, and we'll cross multiply and solve for x. So I have 18x equal to 10 times 27, 270, and divide by 18 on both sides. Should be 15, I think. Just make sure. It is 15. So 15 meters is the height of that. So I said this is a very old problem. The old time is measure the pyramid, and Thales is the guy and measure the height of the pyramid. Kind of difficult to get to the bottom of the pyramid, but assume that we can, and we find the shadow of the pyramid, which is the height, will be the same as any object, any control object. Let's say we have 1 meter object and cast a shadow this much. Using similar triangle, we can find the height of the pyramid. Later on, there's a different way to do that, but for now, similar triangle. Okay, with that, we finish section 1.2. I will go to 1.3. Pythagorean identity, Pythagorean theorem, and distance formula. So in a square, in a right triangle, the one that face the square, the one that face the right angle is called the hypotenuse. And because the right angle is the biggest angle in the triangle, that also the longest side. So hypotenuse is the longest side of a triangle. And the Pythagorean theorem says a square of that longest side, is equal to the sum of the square of the other two sides. So a square plus b square is equal to c square. Okay, and look at the proof. Okay, now let's say we have a triangle ABC. A, B, and C. Now we stack them differently. So this shortest side is A, this is B, and this is C. And this is A, B, C, A, B, C. So we have that. Now let's calculate the area of the big square. Area of the big square. Sorry. Oh, shoot. Okay, let's change. A is the shortest side. B is the longer side. So shortest, longer, shortest, longer, shortest, longer, shortest, longer. Okay, good. So in that case, for the big square, I can say the big area equal to a square of A plus B. A plus B by A plus B. That area, the big area. Now I square them, meaning multiply by itself. A times A is A square. A times B is AB plus AB plus B square. AB plus AB is equal to 2AB and B square. So that gives us the area of the big area, the big square. Now, that's one way to do it. Another to do it is to find the area of this square. Of course, C by C, that area won't be equal to C square. And then we have 4 little triangle here. Little right triangle. And the area of that triangle is 1/2 base times height. And we have 4 of those. So we have that triangle plus 4 of those. So the C square plus 4 of this, and 4 of them, each one is 1/2 base times height. So we have C square, and 4 times 1/2 is 2A times B. So the big area is C square plus 2AB, one side of the equation. The other side of the equation is C square plus 2AB. The other side is A square plus 2AB plus B square. So both of them equal the big area, therefore equal each other. So we have A square plus 2AB plus B square equal to C square plus 2AB and minus 2AB on both sides. So with that we have A square left with B square and C square. Okay, so that proof. And apparently the proof for Pythagorean theorem, there will be 100 of proof like that. And so this is just one of them. This is another one. This, I think I wrote them terrible. Not supposed to be like this. It's supposed to be okay. A, B, and shoulder side B. So this would be C. Yeah. So this proof, I think, is from a U.S. president. Last name is Garfield, maybe James Garfield, if I remember correctly. But yeah, U.S. president. Do that. So the area, pretty much what this look like, it's just you cut this in half. That exactly that. So in that case, whatever we do here, cut in half, we're going to have this. We're not going to do for this one. The important result is the sum, the square of the longest side equal the, the square of the longest side is equal to the sum of the square of the other two sides. Okay. Here's some application problem. A 26-foot ladder placed 10 feet away from a house reach the top of the chimney. So we have a chimney. So try to draw a house here. So that's the chimney. See, that's the house. Okay. Okay, close enough, I guess. And this is the ground. A chimney by a house. And we lean a 26-foot ladder. This is 26. And we assume that the chimney is perfectly vertical. If it's not, it's a real problem here. And it's 10 feet away from the house. The question, so that's what we have. How high is the top of the chimney to the ground? So the question asks us to find this length. This length. X. And again, we assume that it is the perfectly right triangle here. Otherwise, it's not going to work, right? Otherwise, we don't have Pythagorean theorem. So 26 facing 26 is opposite from the right angle. So that is the longest one. And Pythagorean theorem, we have 10 square plus x square is equal to 26 square. Now just solve for x. 10 square is 100. X square and 26 square 676 minus 100 on both sides. So x square is equal to 576. And now we have the square root of 576 is 24. So the height from the top of the chimney to the house to the ground is 24. The unit is feet. So it will be feet. So Pythagorean theorem for right triangle. Now I forgot to mention one thing. Pythagorean theorem, the converse is also true. So if we have the right triangle, we have this this equation. If we have that equation, then it have to be a right triangle. So on a big scheme of things, if you build a house, if you build a big triangle, and if this happen to be like in this case, if you know the measure is 10, 24, and 26, those relation, then we say that that angle have to be a right angle, because this have to be a right triangle. So the right triangle, we have the Pythagorean theorem. For that Pythagorean theorem, if we have this, it has to be a right triangle. The converse is also true. Okay, now look at this right triangle again. We have three sides, Pythagorean theorem. So we have x squared plus this side square equal to 4x minus 3 square. Now, a square is multiplied by itself. So 3x plus 5 and 3x plus 5. For x minus 3 is 4x minus 3, 4x minus 3. Multiply it out. 3x times 3x, 3x times 5, 3x times 3x, that's 9x squared, 3x times 5, 15x, 5 times 3x, 5 times 5, that's 15x, plus 25, equal to, do the same thing, multiply, 4x times 4x, 5x times minus 3, so 16x squared, minus 12x, minus another 12x, plus 9. Now let's simplify. Combine like terms. X squared plus 9x squared. That 10x squared. 15x plus 15x. 30x. Plus 25. Wait a minute. Sorry. That was 3. Yeah. This is long day. I'm too close to the page. Should be 3. Sorry. So 9x squared. 3x times 3, that is 9x. And 3 times that also 9x. Sorry. And then 3 times 3 at 9. Okay, oh nice. Okay, 9x and 9x, that's 18x. And then plus 9. That's 16x equal to 16x squared minus 12 minus 12, that minus 24x plus 9. Alright, let's move everything on one side and solve for it. Let's move to this side because of the 16x squared is bigger than this. Or the doesn't matter. Let's move x squared together. The 18x and the 9. Okay, so everything here is 0, and we have 16 minus 10, 6x squared minus that, that is 42. 9 cancel out, so 6x squared minus 42x. Now we just solve for x. We can just factor out the 6x. We left with x minus 7. That equal to 0. So 6x equal to 0, or x minus 7 equal to 0. So if x equal to 0, x equal to 7. And x cannot equal to 0 because the signs have to be positive. So we rule that out. So the answer is x equal to 7. So in this case we have 7, 4 times 7, 28 minus 3, that's 25. 3 times 7 is 24. 3 times 7, 21, plus 3, 24. So we have that triangle, 7 square plus 24 square is 625, and 25 square also 625. So yeah, x equal to 7. Right, so we haven't done any trigonometry. Yes, just the ratio, triangle, Pythagorean theorem. Now this is the first time we define a trigonometric function. So if we have the coordinate system of the x-axis and the y-axis, and we form a right triangle, and if we have a point P has the coordinate of x and y. So this is x and this is y. So I have x, I have y. And r is the distance from P to the origin. So x squared plus y squared equal to r squared. Right. So that be our theorem. But now we define 6 trigonometric functions. That function from a point P connect to the origin and from that angle theta. And now the trigonometric is a function of the theta. And there's 6 functions. The name of that is sine, will be, if I spell it out, it will be sine, cosine, abbreviate COS, tangent is tangent. This is CSC, will be cosecant. This is secant. And that is cotangent. So that's just a name for it. Later on I will explain, I will tell you a story why those names. But, okay, for now, it's just a definition. And we say the sine of an angle is y over r. Sine of an angle corresponding to the point xy is y over r. Cosine is x over r. And tangent is y over x. Cosecant r over y. Secant r over x. Cotangent is x over y. Now just do 6 ratio. Definition. So sometimes definition we just have to memorize it. And this is that. In the next section there's a different way to define trigonometric function. So we might do something is easier to visualize, to understand, and to memorize. But for now, just memorize that. Okay, so let's look at an example here. If the terminal side of an angle in a standard position, it have to be in standard position. So the initial is the positive x-axis, corresponding to the point 3 and 4. So let's draw this out. The point 3 and 4. X equal to 3, y equal to 4. So say 3 and 4. So that point. X equal to 3, y equal to 4. And from there, we connect to the origin. With that, we form an angle in the standard position. We might say that directed angle, counterclockwise. Okay, so that is the angle corresponding to the point 3 and 4. If we draw a triangle, a right triangle, this is y is equal to 4, and this is x equal to 3, and this is r. We don't know, but that should be very easy to find. Pythagorean theorem, x squared plus y squared is r squared. So 3 squared plus 4 squared is equal to r squared. 3 squared plus 4 squared, that's 25. So now we have 25 equal to r squared. And with that, r is 5. So my picture is on my camera, face camera is on the way, but r is equal to 5. So you have x is 3, y is 4, and r is 5. Let's write that out. Yeah, that works. X is equal to 3, y is equal to 4, and z is equal to 5. I'm sorry, r is equal to 5. There's no z. Right, and now we have 6 trigonometric functions, and like I said, for now, just have to memorize it. Sine is equal to y over r. So y over r 4/5. Cosine is x over r 3/5. Tangent is y over x. That ratio is y over x 4/3. Okay, once again, this is just definition. In the next section, there's a connection and it's easier to understand, easier to memorize. But for now, just definition. Cosecant. I'm going to flip this r over y. R is 5 and y is 4. Secant is r over x. So just going to flip this 5/3. So just a ratio. And cotangent is x over y is 3/4. Okay, so that's just a ratio. I'll just have to memorize this ratio. Okay. I think I'm gonna stop here because this is a good standpoint for next time on Monday. So at least we've done something this week.